Welcome to my channel Math Magic. Today we will do complex number. So see in my channel solve so many mathematical problem easiest way. Okay, now let's start today complex number. Complex number. Okay, so before start the complex number, first of all you see what is imaginary number. What is imaginary number? See, x square plus 1 equal to 0. Okay, now solve this quadratic equation or solve this equation. We do x square equal to minus 1 or x equal to root over of minus 1. Okay, so see one thing, root over of minus 1 it cannot possible to solve root over of minus 1. So root over of minus 1 is called imaginary number. Okay, I repeat, root over of minus 1 is called imaginary number indicated as I. So we write I equal to root over of minus 1. Okay, that is called imaginary number. So I is called imaginary number. See, in general, the square roots of all negative real number are called imaginary number. Okay, so now come to the complex number. A number of the form of a plus ib, a number which is form of a plus ib is called complex number indicated as z. Okay, so represent as z. Z is equal to a plus ib. It is said to be a standard form. This is z equal to a plus ib. This is the standard form of a complex number. Okay, now see, then a is called in this part, in this a is called real part and b is called imaginary part. Okay, and denoted by rez. Rez, that means real number of z. Okay, that is a, and imaginary, that is im z equal to b. Clear? So this part is called real part and this part is called imaginary part. Okay, now represent this in a graph. See here, we draw two line, one is x-axis, another one is y-axis. Okay, so in complex number, how to represent in a graph, that is x-axis is called real axis and y-axis is called imaginary axis. So in x-axis, every small part we take 1 unit. Okay, and in y-axis every small part we take I unit, that is 1 2 3 4, and in y-axis 1i, 2i, 3i, 4i, dot dot dot. Clear? That is why y-axis is called imaginary axis. Now see, suppose we take a number z is equal to 3 plus 2i. Z is equal to 3 plus 2i. Okay, how to represent 3 plus 2i in the in this graph? Okay, see here, 3 is real number, so 3 go along x-axis, so 1 2 3. Okay, now 2i means go to the y-axis, so 1 2, this point 3 comma 2 is the representation of this complex number z is equal to 3 plus 2i. Clear? Now this plane or this graph is called, another name is called Argand plane. Okay, so this graph is called Argand plane. Clear everyone? Now suppose the distance, suppose this point we take P. So what is the distance between OP? Okay, what is the distance between OP? This is called modulus of Z. See, therefore modulus of Z, okay, equal to root over of a square plus b square in standard form. A square plus b square. A and B, A is the real part, B is the imaginary part. Now in this equation Z equal to 3 plus 2i. So mod Z equal to root over of 3 square plus 2 square. So what is the answer? 3 square means 9, 2 square means 4. So 9 plus 4 equal to 13. So root over 13. So in this complex number, z is equal to 3 plus 2i. The modulus of z, that is root over of a square plus b square, that is 3 square plus 2 square equal to root over 30. Okay, modulus means the distance between the point from the origin, that is OP. This is the modulus. Okay. Now, if we draw a perpendicular line P from P to x-axis, and we get a right angle triangle. So, according Pythagoras theorem, what is the distance of OP? That is hypotenuse. What is the distance of hypotenuse? That is base square plus root over of base square plus perpendicular square. So, we get OP. That is why modulus Z equal to root over 13. Clear, everyone? Now see. Clear, everyone? Now, suppose Z is equal to A plus IB. This is the standard form of a complex number. Already I told. Okay. Now see, conjugate of complex number. Conjugate means opposite. Conjugate of complex number. Okay, represent as Z bar. That is A minus IB. That is the conjugate of complex number. Okay. Now, some properties. Look at some properties of the conjugate of a complex number. Number one, look at some properties of a conjugate of a complex number. See, number one, Z bar, then bar, again bar. So we get Z. Okay, Z means complex number, any complex number. Okay. Now, number two, Z1 plus Z2. We have two complex numbers. Z1, one complex number, Z2, another complex number. Z1 plus Z2, Z1 plus Z2 equal to Z1 bar plus Z2 bar. Okay. Then number 3, Z1 minus Z2. Okay, bar. That means Z1 bar minus Z2 bar. Okay. Clear, everyone? Now another one is number 4. Z1 into Z2 bar. That is Z1 bar into Z2 bar. Okay. Another one, number 5. Z1 divided by Z2. Okay. Then bar. That means Z1 bar divided by Z2 bar. Clear? This is the properties of conjugate of a complex number. See carefully. Okay. Now come to some examples. Okay. See carefully. Example number 1. Okay. Z is equal to minus 3 minus I. Minus 3 minus I. This is the complex number, and in standard form A plus IB. Z is equal to A plus IB. This is the standard form of any complex number. Okay. This is real part, this is imaginary part. Now Z equal to minus 3 minus I. So real part equal to minus 3 and imaginary part equal to minus 1. Okay. First of all, arrange properly. That means standard form. In standard form, see how? Minus 3 plus minus 1 into I. Okay. I means, what do you mean I? I equal to root over of minus 1. Already I told. Okay. So this is the arrange Z in the standard form. That is A plus IB. Now the question is, question number 1. Find REZ. REZ. That means real number of Z. What is the real number? Minus 3. Okay. Then second question. IMZ. That means imaginary part of Z. That is minus 1. Imaginary part of Z, that is minus 1. Okay. Then next question is Z bar. That means conjugate of Z. Conjugate of Z equal to minus 3 plus I. Okay. Change the sign. Conjugate of Z, formula already written. So conjugate of Z equal to minus 3 plus I. That is conjugate of Z. Okay. Now next question is find modulus of Z. Okay. So modulus of Z, the formula is root over of A square plus B square. Okay. So Z equal to minus 3 minus I, A equal to minus 3, B equal to minus 1. So modulus of Z equal to minus 3 whole square plus minus 1 whole square. So we get 3 whole square means 9 plus 1. So root over 10. Okay. That is the modulus of Z. Clear? And must be positive because modulus of Z means distance. That is why we take positive side. Clear? Now come to the second example. Come to the second example. Example number 2. Okay. First of all, look at the question. 1 minus I into x. 1 minus I into x plus then 1 plus I into y, 1 plus I into y equal to 1 minus 3i, 1 minus 3i. This is the question. Okay. Now see, 1 minus I into x plus 1 minus I into y equal to 1 minus 3i. Now the question is find the value of x and y. Okay. See how to solve this problem. First of all, okay, see carefully, LHS and RHS, comparing both sides. RHS already arranged in the standard form, but LHS not arranged. So first of all, we arrange the LHS in the standard form, that means A plus IB. How to arrange this? See carefully, multiply x minus I into x plus y plus I into y is equal to 1 minus 3i. Now x plus y, one equation, another is minus ix plus iy, okay, equal to 1 minus 3i. Now take x plus y plus minus x plus y into I equal to 1 minus 3i. Now LHS is arranged properly in the standard form, that is A plus IB. Okay. Now comparing both sides, that means LHS and RHS, comparing both sides, we get therefore x plus y equal to 1, because real part equal to real part. Here real part is x plus y and here real part is 1. So x plus y equal to 1, we get equation number 1. Then again minus x plus y equal to minus 3, we get equation number 2. Clear? Comparing both sides, real part equal to real part, we get x plus y equal to 1. Then imaginary part equal to imaginary part, that is minus x plus y equal to minus 3. We get equation number 2. Now solving these two simultaneous equation by any method, we get x equal to, okay, we get x equal to 2. We get x equal to 2. Solving this equation by using any method, we get x equal to 2 and y equal to minus 1. See carefully, we get x equal to 2 and y equal to minus 1. Clear everyone? Okay. Now another example, see another example. Example number 3. The question is, example number 3. The question is minus 5 plus 3i, minus 5 plus 3i whole square. Okay, this is the equation. Now the question is arrange the equation in the standard form, that means complex number form. Okay, see how to solve. First we simplified this equation in a plus b whole square. All of you know a plus b whole square. What is the formula? A square plus 2ab plus b square. So we just simplify it, a square, that is minus 5 whole square plus 2ab, 2 into a into b plus b square 3i whole square. So we get 5 5 25 minus 5 to the 10, 10 3 the 30, 30i, then plus 9i square. Now see, I equal to root over minus 1. So I square equal to root over of minus 1 whole square, that is minus 1, only minus 1. Okay, I repeat, I equal to root over of minus 1. So I square equal to minus 1. Squaring both sides we get. Okay, now put the value of I square, that is minus 1. Just put it. 25 minus 30i minus 9. I square means minus 1. So 9 into minus 1, that is minus 9. So 25 minus 9, that is 16. So 16 minus 30i. Okay, so we get 16 minus 16 plus minus 30 into I. This is the standard form. Okay, this is the answer. Z is equal to 16 plus minus 30 into I. So real part is 16 and imaginary part is minus 30. Okay, and next example, example number 4. Example number 4. Okay, here is given z is equal to 3 plus 3 minus root over 7i, that is given 3 minus root over 7i. Find z inverse mod z inverse. Okay, find mod of z inverse. Okay, see how to find. First of all, z inverse means z to the power minus 1. So what is the z, what do you mean by z to the power minus 1? That is 1 by z. So you write z to the power minus 1, that is 1 by z. So 1 by 3 minus root over 7i. Okay. Now multiply numerator and denominator, okay, with conjugate of 3 minus 7i, that is 3 plus root over 7i. Okay, here is 3 minus root over 7i into 3 plus root over 7i. Clear? Multiply numerator and denominator with the conjugate of 3 minus root over 7i. Clear? Now see what happened. 3 plus root over 7i in the numerator and denominator. See, a plus b into a minus b. So directly use the formula a plus b into a minus b. That is, we get a square minus b square. So here is 3 whole square minus root over 7i whole square. So 3 plus root over 7i divided by 3 whole square means 9. Root over 7 whole square means 7. I square means minus 1. Okay. So 7 into minus 1, that is plus 7. 7 into minus 1, that is plus 7. So we get 3 plus root over 7i divided by 9 plus 7, that is 16. So this is the value of z inverse. Okay. So simplified it, 3 by 16 plus root over 7 divided by 16 into I. Right? Simplified it in the standard form. That is 3 by 16 plus root over 7 by 16 into I. Clear? So we get the standard form. Now modulus of z inverse, see carefully. Modulus of z inverse equal to root over of 3 by 16 whole square plus root over 7 by 16 whole square. Now see what we get. That is 3 3 the 9, 16 16 the 256 plus root over 7 whole square, 7 divided by 256. Okay. So 256 is the LCM. 256. 9 plus 7, that is 16. So root over of 16 by 256, that is 1 by 16, that is 1 by 4. This is the final answer. Clear everyone? Okay. So today up to this. Subscribe my channel. Thank you.